So here is the Tinkercad. You can go to the tinkercad.com and if it asks, suppose I just log out myself from here. So when you open this tinkercad.com, just it will ask whether to join now or sign in. You can just sign in by using any of your Google account. You can use sign in with Google, or if you have an Apple account, you can use that also. So just sign in with Google account. I will use one of my account. Here is one of my Google account. So you can see this page will be open. If you are new to the Tinkercad, it will ask for some demo. You can skip those demo also. So we will go to the circuits. We'll make some circuits. So go to the circuits, create new circuit. So now this page will be open. You can see these type of instruments, virtual instruments are there. So circuits are there. So we will utilize this circuit components to make our circuit. So our first experiment is the diode characteristics. We have to study the forward and reverse diode characteristic. So you can change the name of your work here. You can double click it and you can put the name diode characteristics and just enter it. You can see the name of your work is changed now. It is diode characteristic. So if you are in the lab, this Tinkercad create a very similar virtual environment as you can find in the lab. You need a breadboard, you need a resistor, multimeter, CRO to perform any experiment. So after understanding this, what is the diode characteristic, what is the first thing we need? We have to ask our lab attendees to what components we require. So first thing is you have to ask a breadboard. You can type here breadboard. Okay. So here are different kind of breadboard. So in the lab you usually find this kind of 840 pin breadboard. You can drag and drop here. You can see here. Okay. So first thing you need to know about this breadboard. This breadboard is having virtually salt ports. For example, if you touch here, it shows a green line. Okay. Let me zoom in. If I touch here, you can see this line is virtually salt. Okay, these are salt inside. So if you apply a 5 volt here to the wire, so the entire line will be at 5 volt. If you apply here at the same, just like that. Okay, so if you apply 10 volt here, it will, all the lines are 10 volts. Okay, so they are salted horizontally, and here they are salted vertically. You can see 15th lines, all are salted. 16th line salted. Okay, so there are 840 pins. Okay, this outside pin we generally utilize to apply the power supply. Okay. This plus and minus That doesn't mean you have to apply the plus voltage here or minus voltage here. It is just for the notation. Okay. Now the first thing you require for the diode characteristic experiment is diode. You can click here, or you can go to this all menu. You can click components. These are the basic components, and you can also see all menu. In the all menu you can find resistor, so drag and drop here, because for this experiment we need this resistor. You can find diode here, so just drag and drop diode here. You can scroll down to zoom out and scroll up for zoom in. And to rotate this, you can click here to rotate any component. You can click here at any component to change the value. For example, if you require 1 kilo ohm, it is okay, and if you want pico ohm, milliohm, ohm, kilo ohm, mega ohm, giga ohm, so you can change its value. This is diode. So in the lab you can find this kind of diode. So this black line shows the P region and the silver strip shows the N region. So this one is P and this side is N. Okay, so we have to rotate it also. Okay, first click on the component and then rotate. Okay, so let's connect this. According to the circuit diagram, we need, okay, so in between this resistor and this diode P region, according to this diagram, so in the resistor, so this is the circuitry. This is a forward characteristic that I have taken from the virtual lab, that is explained by Rishabh sir. So you can see in the path we have to connect the ammeter in series and the voltmeter parallel to the diode. So the voltage applied is different than the voltage we are measuring across the diode. Okay, so we need two multimeters in the lab. Multimeters are available. One we will utilize as ammeter and second we will utilize as a voltmeter. So let's see. Here are the multimeters. If you don't, here it is multimeter. Just drag and drop. And we need two multimeter and we require a power supply, a DC voltage source. As you can see here, this is a DC voltage source. So we have a power supply. Just drag and drop here. You can see. So we require to connect DC. The positive part of DC is connected to the resistor here. Let's connect this to the resistor here. Okay, this is the positive part, and in the lab it is generally in the red color. So we will utilize a red color, and for the ground or negative part we utilize a black color wire. So we will connect it to here, make it short because we need a lot of ground. And One more thing which is important in the circuitry is that entire ground, either for this multimeter or this oscillo function generator or this power supply, the ground should be common. This is the basic of the circuitry. Ground should be common. Okay. So next multimeter, you can see this is a negative, so we'll connect it to the ground, because if I connect this entire line is now grounded. So I can connect here to make this ground. So change the color as black, so we can, by seeing, we can determine this is the ground wire. And this voltage we have to measure across the P. You can see the P side and the ground, in between the ground. Okay, P should be connected to the voltmeter positive and ground should be connected to the N side. Okay, so this N side should be connected to the ground also. So make it connect to the ground, make it black because it is also grounded. And this one is the power measure, make it red. Okay, this is for the voltage measure. Now to connect a multimeter or ammeter, we have to connect it is in the series, and for the voltmeter we connect in the parallel form. So let's connect in series. Resistor, then in series with red is connected to the black is connected to the diode. Connect the black to the diode. You can see here, this is the positive, this one is positive and this one is negative, and this one is the positive and this one is the negative. Okay, so I have connected resistors to the ammeter positive, and then P side to the voltmeter positive, N side to the voltmeter negative. Okay, and so on. So the negative part of the ammeter is connected to the P side. So here we have done so. Let's so this one is 100, so this will be red. Now I think connection is completed. Let's check one more time. Here is the positive DC supply. It is connected in series. There is a resistor, then in series there is a meter, and then in series there is P side, then N side, and then this should be grounded. Okay, there is a multimeter connected to the anode of the diode, and this cathode should be grounded, and it is grounded. Okay, make this wire also black. Okay. This is not necessary, but in the lab you will feel like that only. Okay, this wire is red, this wire is black. So now you can start this simulation. Here the ammeter, voltmeter and resistor meter. Okay, it can measure this. So just click on A side. Now it can measure a current, and it is also in the voltmeter mode. Okay, so you can now change the DC power supply. Start with 0. Now you can increase this voltage. You can see the voltage rating, voltage across the diode and the current simultaneously. You have to note down. Okay. Increase incrementally. Okay, at the 39 when the diode voltage is 395 millivolt, the current is 0 ampere. When the diode voltage is 516 millivolt, diode current is 484 microampere. When the diode voltage is 560 millivolt, it is 2.64 milliampere, and so on. You have to take at least 20 readings, 15 readings minimum to make a proper graph. Okay, so in this way you can perform the experiment in the lab. Okay, you have to take these readings and you have to put this in either Scilab or you can put in the Excel sheet to draw a proper graph. So this is the forward characteristics. Okay, this is the forward characteristic. Now to observe the reverse characteristic, we have to just reverse the polarity of this diode. So after stop this simulation, let's change the orientation of this diode. Now this side is N is connected, and here P is connected. So now start the simulation. See, start with 0, okay. 2 volt, 6 volt, 2.6, 3 volt, 5 volt, 6 volt. There is no current because it is in the reverse bias. 19.2, 20.8, and so on. So whatever voltage we are applying, there is no current unless this diode goes in the breakdown region. Okay. So normal PN junction diode don't go in the breakdown region then in the small voltage. So in this way you can perform this experiment. You have to make these readings. You have to write these readings in the observation table. You can plot these readings by using MATLAB, Scilab, or any graphical tool like Excel. Okay. So you have to do this. Okay. You have to perform this experiment on your own and put the observation table. Put the reading in the observation table. Okay. Thank you.